Hey everybody, this is Miss Eisencraft, and I'm going to discuss today how to graph from factored form. Factored form is just another way to write the quadratic function, and when it's written this way, different features are showcased. So when something is written in factored form, you'll recognize it because it has been, the name for it is factored or unmultiplied. So if there's an a value other than 1 or -1, that will be out front, and that will always tell you if it opens up or down. Up or down, and all of them today are going to be, and on your homework, are going to have an a value of 1 or -1. Then you have like these two expressions in parentheses, and they actually could say plus or minus, but the equation is written x minus, and when they're written this way, the p and the q are called the roots, okay, or the x-intercepts, or the solutions. And as you know, a quadratic function, when you graph it, makes a U-shaped parabola, right? So the roots or the x-intercepts, typically you're going to have it cross twice. And so these two numbers here are these values here. Okay, so these roots, x-intercept solutions. So we're just going to jump into some examples where an equation or a function is already written in factored form, and we're going to kind of dissect it and say, okay, what are the roots? What's the axis of symmetry? And then how could we sketch a graph without having to do tons and tons of like calculation and math? So this first one says we have y equals x minus 2 times x plus 4. So the roots are, or the x-intercepts or the solutions, they come from these numbers here. Now, since you are looking at where the U-shaped parabola would cross the x-axis, that is where the y value is 0. So what you're actually doing is you're trying to figure out what number could you plug in here so that this little set of parentheses would equal 0. Because if it did, it would make this whole expression 0 and make the dot on the x-axis. And then you're also asking, what value could you plug into this x to make this set of parentheses 0? So it ends up being the opposite of this number here. So the roots are what x value could you plug in here to make this equal 0? So the root is x equals 2, positive 2, and here x equals -4. If you want to write those as coordinates, it would be 2, 0, and -4, 0, two separate points, okay? So the roots or the x-intercepts or the solutions actually tell you, excuse me, where these 2 points are. Okay. All right, so those go right down there. And they are always opposite of these numbers here. Okay, so now the axis of symmetry, we know that a parabola is symmetrical, so these roots, if we count to the middle, we could find the axis of symmetry. So we're on a number line, and we have positives and negatives. So right in the middle of -4 and 2, if you just kind of count to the middle, 1, 2, 3, 4, 5, 6, they're 6 apart. So you count 3 in, and it looks like the axis of symmetry is right there at -1. Kind of hard to see. Okay, that is the middle. And all I did is count from the middle of 2 and -4, 3 units in from each side, and I landed exactly at -1. So another way to think about this is count to the middle from your roots. Okay, and the axis of symmetry is x equals, in this case, -1. So now you know the vertex has to lie on that line. Well, where is it? Is it up here? Is it down here? And how far apart? So what we want to do is, well, we could look at our a value. Since our a value is the number out in front of the parentheses, and there's nothing there. The A value is really 1. So that means it's going to follow the typical pattern of, let me just go ahead right here, even though this is step 4, A value. The typical pattern of a parabola with the A value of 1 is out 1, up 1, out 2, up 4, out 3, up 9. You could actually use this, since the vertex has to lie on this orange line. It looks like these dots were made by going out 3. And so, and the U-shaped parabola is going up because it's positive 1. So since it went out 3, they must have counted, if you look over here, up 9. So you could go backwards and go in 3 and down 9 and say, oh, that must be the vertex. Whoopsie daisy. That's just from looking at the pattern. You also can do it mathematically by plugging in the x value that we found into the equation. You just have to be careful with all the negatives to not make a mistake. So to find the vertex, again, you could use the pattern. And since it was 3 away from the axis of symmetry and the A value is 1, we went in 3 and down 9. Okay. The other way to do it would be to plug in -1 into this equation and figure out the vertex. So you would do y equals x minus, oopsie. What I'm going to do, I didn't mean to write the x's. I am going to plug in -1 in there and in there. Okay, so then I would have y equals -1 minus 2 is -3. And -1 plus 4 is +3. Wow, look at that. Y equals -9. And we knew the vertex was -1 something. It's -1, -9. So the vertex is -1, -9. We already had the x value from the axis of symmetry. Okay, now, if you just try to connect this, it'll look like a V. So make sure you do, this is the vertex. Do the out 1, up 1, 1, out 2, up 4, and out 3, up 9. That's already there. And there you go. There's the first one. All right, let's quickly do the second one. So much fun. This next one, all right, it's negative. So the A value is -1. A value, I'm going to write that down here. So it's going to go down. Don't forget that. Okay, but typically out 1, down 1, out 2, down 4. Okay, the roots. The roots are whatever values you would have to plug into x to make this 0. So you'd have to plug -5 in there. And then what could you plug into 1, or sorry, what could you add to 1 to make this 0? So the roots are -5 and -1. They're always just the opposite of these. Okay, so you would have -5, 0, -1, 0. These do not go together. They're two separate points. Common mistake there. So we're going to plot those bad boys over here, -5, -1. All right. Now we know a parabola is symmetrical, so we're going to count in from the roots. These are only 4 apart, so you're going to count in 2, and you're going to land at -3, counting to the middle. So remember, it's find the middle. That's the key word. If you're like, where'd you get that number? Once I had my roots, I counted to the middle. Now, since the A value is -1, we know it has to open upside down, so the vertex has to be up here. So I'm going to show you, okay, so typically it's out 1, down 1, out 2, down 4, out 3, down 9. And these purple dots here are out 2 from this vertex up here. So the out 2 is down 4. So if we go backwards, into up 4, 1, 2, 3, 4, That should be the vertex, but let's make sure mathematically that's correct. So we're going to take the equation and we're going to plug in -3 where the x is. And it's okay to use a calculator here if you want to. Lots of opportunities for mistakes when you work with negatives. -3 plus 5 is 2. This negative out here is separate. What did I do? I made a boo-boo. This is 1. Looks like that's not going to work. I copied it down wrong. So sorry. -3 plus 1 is -2. Okay, so you're going to go 2 times -2 is -4. The opposite of -4 is +4. So the vertex is -3, +4. Remember, this part of the vertex is always the x value, the axis of symmetry. Hey, and that's what we found when we just even looked at the pattern. So let's draw the other dots in, out 1, down 1. We have 2 and 4. Let's draw another one since we have room, out 3, down 9. Okay. All right. Good luck, everybody.